Hello students, today we are going to continue with our next topic, that is the ionization energy, or we can also say it ionization enthalpy. In our previous lecture I have explained you the concept of ionic radius, how it is showing variations when we are taking the radius of anion, cation and of neutral atom, and afterwards we have discussed about the concept of the isoelectronic species. And now we have to start with the next topic, that is the ionization energy. So firstly we will see what is the meaning of the term ionization energy. The minimum amount of energy required to remove the electron from the outermost orbit of an isolated atom in the gaseous state is known as the ionization energy. Means here I am having freely isolated atom. Clear? Now if I have to take one electron from this atom, then it will going to change into the cation. Clear? So to remove one electron from this atom, I need some amount of the energy. Clear? That has to be released. So the amount of the energy released or required to remove an electron from the valence shell of an atom is known as the ionization enthalpy. Clear? So for removing the electron first time, the amount of the energy that is used here is known as the IE1, ionization enthalpy, for removing the first electron. Clear? And then if I have to remove the second electron, then again I have to provide some amount of energy, and for removal of the third electron again I need some amount of energy. Clear? So this process I can continue. And the thing here that you have to keep in your minds, that is the what is the order for the ionization enthalpies for removing the first, second, third and fourth electrons from the valence shell of any atoms. Clear? We have to see that. Now as you know, to remove the electron from its valence shell, we have to give the energy to the system. Clear? Means the process is the endothermic. Clear? That is change in enthalpy here should be positive always, because energy is absorbed by the atom. Clear? To lose one electron. So now the order, if we are having the ions of the same atom, clear, then the order for the ionization enthalpy will be IE4 always greater than IE3, and then IE2, and then IE1. Why it is like so? Because the pull of the nucleus on each electron was increased when we remove one electron from the valence shell of any atom. So it required more energy to remove the electron as compared to the first time. Clear? For example, I am having the magnesium. Clear? And atomic number of magnesium is 12 and number of protons present should be near about 12 na? And I am taking its cationic form. Clear? Mg plus 2. Now the number of electron becomes 10. In Mg the number of electron 12 na? In Mg plus 2 the number of electron becomes 10 and number of protons will going to be 12. Clear? Here more positive charge is present to attract the 10 electrons towards itself. Clear? If the positive charge, that is nucleus, in nucleus there is the positive charge which has to hold the outermost shell electrons towards itself. Clear? More positive charge, more strongly it will going to attract the electrons from the outermost shell towards itself. Clear? So to remove the outermost shell electrons, in that case when nuclear charge increased, clear, we have to apply more amount of energy na? So according to that we are saying that we need more ionization enthalpy here. Clear? So this trend we have to follow for the ions of the same element. If we are having these separate elements like oxygen and nitrogen, then we have to take in consideration the concept of electronic configuration, which we will discuss in detail further. But here I am just giving you the idea that this concept you have to apply only for the same type of the elements. Clear? Now we have to see what are the factors on which the ionization enthalpy depends. After learning about the factors, how the ionization enthalpy will going to vary along a period and down the group, you can understood in a better way. That's why I am explaining the factors. Clear? In factors, first factor is the size of the atom. Clear? Here I have explained you that ionization enthalpy is increasing. Why? Because of the stronger attractions between the outermost shell electrons and nucleus. Clear? And with these attractions, size also becomes small now. So ionization energy increases with the decrease in the size of an atom or ion. Clear? So we can say ionization enthalpy is inversely proportional to the size of any atom. Clear? So here firstly I am having the size of the magnesium. In magnesium 1s2, 2s2, 1, 2, 3, 4, 5, 6, 7 and 8 electrons now. And in its outermost shell, how many electrons we have to fill? 2 electrons. Clear? That is Mg. And for second time, after removing the 2 electrons, sorry, 1, 2, 3, 4, 5, 6, 7, 8. Clear? Now the attraction with the nucleus will going to increase because of increased positive charge. Here protons 12, electrons also 12. Here number of protons 12 and electrons will become 10. This is the Mg plus 2. Clear? So here size will become smaller because the attraction between the nuclei and outermost shell electrons increased. Clear? So large amount of energy is required if I want to remove electron from here, from this shell. Clear? So now you will get the idea that how I am saying that with ionization enthalpy will going to increase when the size will decrease. Clear? Overall we have to take the inverse relation always. Clear? And second, that is the nuclear charge. Nuclear charge means the effective positive charge that is the present in any atom. Here we can say, again from same example you can take the idea. In case of magnesium, there are overall 5 factors clearly on which on the basis of which I am saying that ionization enthalpy is increasing. Clear? First one is the size, and second one I have to take into the consideration is the nuclear charge. Initially I am having Mg, and second time I am having Mg plus 2. Positive charge on the atom shows that it has lose its electron, means negative charge is decreased in the atom and effective positive charge is more as compared to negative charge. So nuclear charge generally explain the effective positive charge. Clear? Nuclear charge means the charge present in the nucleus that will be positive because neutrons are always neutral na? In nucleus 2 types. Nucleus generally consists of neutrons and protons. So neutrons are not having any charge and the charge in the nucleus is because of the protons only. So that's why here I have written that ionization energy increased with increasing the nuclear charge. More positive charge present in the nucleus of any atom, more strongly it will going to hold the lesser number of the electrons. Clear? So ionization enthalpy is directly related to the nuclear charge. And next is the screening effect of the inner electrons. Screening effect I have explained you earlier that what is the screening effect. the tendency of the inner shell electrons to provide a shield between nucleus and outermost shell electrons. So if shielding effect is poor, then ionization enthalpy will become greater na? And if shielding effect is stronger, then ionization enthalpy will be lesser. Clear? So ionization energy increases with decreasing the screening effect. If screening effect is decreased, means the attraction becomes stronger between the nuclei and outermost shell electrons. If attraction becomes stronger, then large amount of energy is required to remove the electron. Clear? And the next one is the electronic configuration. See, if we are having the more stable configuration, like in the stable configurations I have explained you earlier, that P3, D5 and F7 type configurations. Clear? And fully filled also P6, D10 and F40. Clear? If I am having this type of the configurations, then these are very stable and large amount of ionization enthalpy is required to remove the electron from these subshells or half filled or fully filled orbitals. Clear? And the next is the penetration effect of electrons. The penetrating power of orbital is in the order as S is having more penetration effect as compared to D, then as compared to P, and then D, and then F. So firstly, what is meant by the penetration effect? Means if more penetration power of electron in any subshell, that indicates that it will be closer to the nucleus. And when any subshell is closer to the nucleus, then what trend we are expecting for the ionization enthalpy? Any subshell when closer to the nucleus, then the attraction between the nuclei and outermost shell electron will going to increase, and with increasing attractions, the ionization enthalpy will definitely going to increase. It will become very difficult to remove the electron from those subshells. Clear? And so that subshell will be closer to the nucleus and will be held firmly, more tightly. So consequently, ionization energy required will be high. Clear? So this is the general idea. As we are moving along a period, ionization enthalpy increases because when I have explained you the concept of the atomic size, we have discussed this concept that as we are moving from left to right, the atomic size decreases. When atomic size decreases, then attraction between nucleus and outermost shell electrons becomes strong, and it will result in more ionization enthalpy. Clear? And down the group, size of the atom increased. Clear? If the size of the atom increases, then attraction between here atomic size decreases, and attraction between nuclei and outermost shell electrons will going to decrease. So ionization enthalpy also required in a lesser amount. Clear? It will become very easy to remove the electrons from these type of the groups. Clear? So next we have to see some exceptions in period and group that we will continue further in our next video lecture. Till then, understand this concept completely. Thank you.